Alright guys, this is 10.1b, rational expressions. So the other day we went over the basic introduction on how to graph them. What I'm going to go over in this lesson, and it's going to be kind of short, is the domain and range of each graph. So there are three ways to express domain and range, and we've gone over this before. You can express it using an inequality, so x is greater than 3 or y is less than 2. We have set notation, which has your little brackets over here, and if you're talking about domain, you have x in the front. If you're talking about range, you'll have y. And the way you read that is you have the set of values for x. The little line here in the middle stands for such that, and then you write your condition over here. So x doesn't equal 3, x greater than 5, whatever condition it's going to follow. Then you have interval notation, which is what a lot of you are more comfortable with. Now, when we're dealing with rational expressions, we're actually going to have the union of two different intervals because there's two branches to the graph of the hyperbola that we have. Okay, so there's the three. What I want you guys doing is practicing all three of these notations in this section. So I'm going to start off with our parent function. We have 1 over x, and I'm going to show you what it looks like on the calculator. Maybe you can see it, probably not. Yeah, there you go. Okay, so I'm just going to graph it. We have 1 over x. So you should be familiar with this by now. So there's our graph right there. You know that it's going to look something like this and like this. You know that there are two asymptotes that happen on the axis themselves, right? So at this asymptote here, this is the value where x is equal to 0, and this is y equal to 0. Okay, so y can never equal 0 here for the function, and x can never equal 0 here. Okay, that's where those asymptotes happen. So we're going to use those when expressing the domain and range. If we're going to write it as an inequality, we're going to have 2. We're talking about the domain. So if we look at the right side of the graph, this branch over here, we know that x is going to continue in the positive direction for all values except 0. So x has to be greater than 0. X cannot equal 0. It can also be less than 0 because our graph is going to continue this way to the left. So it can be less than 0, but it cannot equal 0. So we have two inequalities. We have x greater than 0 and x less than 0. Notice that they don't have the equal to signs underneath the inequalities because it cannot equal 0. The same thing for the range. The range goes up to infinity and down to negative infinity. The only value that sorry guys, the only value that it cannot equal is where y equals 0, okay? So that's what we're going to write. We're going to write y is greater than 0 or y is less than 0, right? Because it can go down to negative infinity or up to positive infinity in the y direction. Set notation, that's where you start with your brackets. For domain, we're talking with x. So all values for x such that x does not equal 0. So it can be any value that you want except for 0. And it's going to be the same for y. So any value for y such that y does not equal 0. And that's where our asymptotes occur, or our extraneous values. Okay, so they're kind of go hand in hand. And then interval notation, this is the one that you guys are more comfortable with. So x goes from negative infinity to positive infinity except for 0. So if you're looking at this, we're going to go from negative infinity and then it stops at 0, okay, right before 0. So we have open bracket, it goes from negative infinity to 0, and it's going to be open bracket, or the parentheses here, okay? You do not have that square bracket. That square bracket, we don't have it because it doesn't equal 0, okay? So you don't have that. And then it's the union, right? And then it starts up again at 0, and then it goes to positive infinity. Open bracket on both edges. All right, so here I have a second graph. We know that we're going to have asymptotes at x equals 5 and at y equal to 2. Remember, so those are extraneous values, okay? So x cannot equal 5, y won't equal 2 for this graph either. So if you want to graph it so you can see what it looks like. So we have 1 over x minus 5 plus 2, enter. Okay, so we can see here, x equals 5, we have an asymptote, and at x equals 2, we have an asymptote up here. Okay, so that's going to affect our domain and range for this problem. Okay, so if we're going to write it as an inequality, x can be less than 5 or x can be greater than 5, right? Because here on the graph, if we have this line here in the middle, it can be less than 5 or it can be greater than 5, but it cannot equal 5. Same thing for our range. Our range is going to be less than 2 or it's going to be greater than 2. So if you have your line here in the middle, you have your graph that goes up to infinity and down to infinity, except for at the value of 2 where our asymptote occurs. Set notation, so all values of x except for x cannot equal 5. For a range, all values of y such that y not equal to 2. Okay, and then your interval notation, it goes from negative infinity to 5, or from 5 to positive infinity, and the same thing for the y. It goes from negative infinity to 2, or from 2 to positive infinity. Okay, so that's what we're looking at these graphs. I have one more example for you. Sketch this graph here. Okay, sorry guys. It's for notes for later. Okay, so I have one more. We have 4 over x minus 2. So in our calculator, we have 4 over x minus 2, and we're going to sketch that graph, okay? So you know that we're going to have an asymptote at x equals 2 for this, and I'm sorry, x equals 0 and y at negative 2. So at y equals negative 2, we have an asymptote, and at x equals 0, we have an asymptote right over the axis. So we know our graph is going to look something like this. Okay, so again for our domain, if we're writing it as an inequality, we know that x is going to be greater than 0 or x is going to be less than 0, right? Greater than 0, less than 0, because it's right here at x equals 0. For y, y is going to be greater than negative 2 or less than negative 2, because this is y equals negative 2 here. For our set notation, we have all values for x except for x equals 0, right? So x cannot equal 0. For a range, we have all values for y except for y equals negative 2. And then our interval notation, so I'm just repeating this, guys. I'm just kind of writing this in 3 different ways because I want you to be aware of what it looks like. There's more than one right answer for this. Okay, so x goes from negative infinity to 0, and then again on the other side from 0 to infinity. And then our values for y go from negative infinity to negative 2, and then it hops on over across the asymptote and continues from 2 to positive infinity. Okay, so that's all we're doing here. I strongly recommend that you try to graph these and look at which way they go. I'll go over it a little bit more in class when I see you. If you have any questions, let me know. I have a practice problem for you. Give me the domain and range in all 3 notations. Okay, so I want all 3 of them. Other than that, I'll see you in class.